So for section 6.4, we're going to take a look at slope-intercept form. And before we get there, we're going to have a little review here of finding intercepts. So first of all, the question says, find the slope of the line described by 6x minus 5y equals 30. And we have two different options to find the slope. So the first thing is that we can find the intercepts. And remember, we do that by filling in a 0. So if I want the x-intercept, I'm going to put a 0 in for y. So I'm going to have 6x minus 5 times 0 equals 30. So 5 times 0 is 0, so that's gone. So I'm left with 6x equals 30. And 6 times 5 would be 30, so our x-intercept would be 5. Then I'm going to have to do the same thing for the y. If I want the y-intercept, I'm going to put a 0 in for x. So I'm going to have 6 times 0 minus 5y equals 30. And 6 times 0 is 0, so I'm left with negative 5y equals 30. So negative 5 times what is 30, a positive 30, so y would have to be negative 6 in this case. And then I would put those on a graph. So on the y-axis, our intercept is negative 6, so there'd be a dot there. And then the x, I would have to go over to 5 and put a dot there. And to find the slope, I would find the rise over run of those 2 points. So I would have to go up 6, and I would have to go over 5. So my slope would be 6 over 5. So that's if we found the intercept. Now the other way we could do this is we could take this equation and solve it for y. So we could have 6x minus 5y equals 30. And we have to move the x to the other side. So we're going to subtract that whole chunk. So we would be left with negative 5y, and make sure you pay attention and bring that negative sign down with that. And we can't do 30 minus 6x, so we're just going to write 30 minus 6x. And then to get y by itself over here, we have to divide by negative 5. So we would have y equals 30 divided by negative 5 would be a negative 6. And then a negative 6 divided by a negative 5 would be a positive 6 over 5, and the x is behind that. Now, slope-intercept form is actually mx plus b that we've been talking about. So we're going to flip it around. So we have mx, not m, x, and then we have that negative 6. So the m value is your slope. So in this equation, we got 6/5 in the m spot. So 6/5 is our slope. So there's two different ways to take a look at that problem and figure out how you want to do it. Moving on, I just kind of talked about this. The slope-intercept form is y equals mx plus b. M is our slope. So this is important. You probably should want to write this down somewhere so you have it. And then b is our y-intercept. So for our first here example under slope-intercept form, it says write an equation for the line that has slope of 2 and y-intercept 3. So we are just going to plug in the numbers where they go in mx plus b. So it's going to be y equals, m is our slope, and it said slope was 2, so that's going to be a 2. And b is our y-intercept, and this says the y-intercept is 3, so 2x plus 3. Now we have to graph this function and determine its domain and range. So graphing, we can do two things. You can make a t-table and plug in points, or we can graph the faster way, which is figuring out what is the y-intercept in that equation. So remember, it was mx plus b. B is our y-intercept, so our y-intercept here is +4. So on the y-axis, I'm going to put a dot at +4. And our slope is -2/3. So oops. If you think about that, remember slope is rise over run. So I'm going to rise -2, which means I'm going to go down 2 because negative goes down. And then I'm going to run 3, and 3 is positive. So I have to go down 2 and 3 to the right. So right about there. And then we can graph our lines. And then we have to give the domain and range. The domain is what x values can we plug in here. Well, this line goes on forever, so I can plug in negative x's, I can plug in positive x's, I can plug in any x that I want and still get an answer. So this means that all real numbers is the domain. And then the range is the y value. So going up and down, this line will go on forever. So it'll continually go up and it's going to continually go down. So again, the range would be all real numbers here. There is nowhere that that line is going to stop. All right, and for our last equation, it says a pitcher with a maximum capacity of 4 cups, so that's important, contains 1 cup of apple juice concentrate, so it's already got 1 cup. A faucet is turned on, filling the pitcher at a rate of 0.25, so 1/4 of a cup per second. The amount of liquid in the pitcher, which is labeled A of t in cups, is a function of time t seconds. In seconds that the water is running. So graph the function a of t and write the rule for the function and state its domain and range. So for this, it's going to have to be in the form of mx. In this case, it's going to be mt plus rb. So it told us that the pitcher had a maximum capacity of 4. So that means I can't go over 4, but I could have exactly 4. So 4 is greater than or equal to m. How much is it filling? It's filling at 0.25 cups per second, and it told us t was the seconds. So 0.25, I'm going to make 1/4. I'm going to make that a fraction just so we have that rise over run. And t is our seconds. And then how much was already in the pitcher? Well, we had that 1 cup of apple juice concentrate. So they want us to graph this and state the domain and range. So really, you didn't need to think about this 4 part. You could have left this a of t equals 1/4 t plus 1, and then we can graph it. So our y-intercept is 1, and our slope is 1/4, so we're going to go up 1 and over 4. And then when I draw the line, that's where we have to think about that 4. We can't go over 4 cups in our pitcher. So t, which is really the x value, that was our time. And y, our answer, is how many cups are in the pitcher. So we can't go over 4 for the cups. So if I continue from that last dot that I drew, if I go up 1 and over 4, I'm going to mess up and I'm not going to fit on the page. So I'm going to pause the video and redraw the graph for a second. All right, so starting over, I needed a bigger graph. So y-intercept is +1, so I'm going to put a dot there. Slope is 1/4, so from that dot, I'm going to go up 1 and over 4. Then I'm going to continue. I'm going to go up 1 and over 4 again. Put me about there. And one more time, up 1 and over 4. The reason I did that is because the pitcher only holds 4 cups, so I can only go this high. I can't put any more in that pitcher. So my line is actually going to be right here. And what happens is I can't go into the negatives either because that's our seconds, our x values. We don't have negative seconds. So this is going to be the graph that shows what can fit in that pitcher. Now, as far as the 4, we can't have any more than 4 cups in that pitcher. So these points on this line are the different mixtures that we could have. So for instance, our first dot is at 0, 1. So if I don't, after 0 seconds, I haven't put any water in there, then I have 1 cup because I have that apple juice concentrate. Over here, the next dot is over 4 and up 2. That means that water has been running for 4 seconds, and now I have 2 cups in my pitcher. And then here is 8, 3. So after 8 seconds, there's 3 cups. And then this last one, after 12 seconds, there is 4 cups. So you have to think about the word problems and what does the x and y represent in these cases. So write the rule of the function, which we already did, and state its domain and range. So the domain are all positive numbers because we could let the tap run for 2.5 seconds. It doesn't have to be a whole number. It doesn't have to be just those 4 dots. It can be anything in that line. But do notice it starts at 0 and it only goes to 12 seconds. So 0 is our starting point. Has to be a number greater than 0 or equal to. So x is greater than or equal to 0. Notice the alligator, the inequality mouth is open towards the x. And then x has to be less than or equal to 12. So basically what that inequality shows us is that x is between 0 and 12. And then for our range, which is our y values, we're going to look over here. Well, we started at 1. That's our lowest value. And then our largest value is at 4. And we're talking about y for the range. And again, y has to be greater than or equal to 1, but less than or equal to 4. So in other words, y is between 1 and 4.